Okay. Hello. Hopefully everyone can hear me okay. Hi. I'm David Broom. I'm the New Build Partnerships Director for Kensa. I'm chairing the session today talking about how we go around scaling up the deployment of heat pumps to meet the decarbonisation challenge. Before I introduce our guests, just a little bit of background about Kensa for those of you who don't know us. Kensa, we are a ground source heat pump manufacturer. We've been building ground source heat pumps for over 25 years, so I've been involved in renewable heat way before it was has become cool. And over the last 10 years or so, we have pioneered the use of networked heat pumps as a method for deploying heat pumps at scale for kind of large scale projects. And it's kind of tackling heat is an absolutely critical element of how we go about decarbonisation at scale. If we're going to meet our legally binding targets of 2050 to be net zero carbon, we have to be able to tackle heat. And the context of that's kind of never been more kind of widely prevalent. Pretty much every week now you turn on the news and you see some kind of climate-related disaster somewhere on the globe. So all of the stuff that we were worried about going back kind of 5-10 years ago of what the potential impacts could be on the climate and on the environment based on increases in carbon emissions are actually now coming to fruition, and we're seeing that on a weekly basis. And heating homes and businesses makes up for around 20% of those kind of carbon emissions. So it's an absolutely vital element that we have to tackle to meet decarbonisation. And another kind of reason why it's a really tricky element of decarbonisation is it impacts each and every person in the UK. It impacts how we live, how we operate in our homes and in our businesses. So unlike kind of the decarbonisation of the grid that just kind of happens in a field of PV or an offshore wind turbine, this is decarbonisation that's happening in people's homes and affecting kind of how they live their lives. On top of that, we've got kind of the geopolitical kind of environment at the moment. So everything that's going on globally in the political system means that energy security is kind of way more prevalent than it has ever been before. So as fast as possible, transitioning to remove our reliance on kind of imported gas is kind of absolutely key. We've got the ability to increasingly produce our electricity in the UK and have much greater level of control on where our energy comes from. And by transferring to renewable heat through electrification, that gives us the opportunity to use that electricity and reduce that reliance on everything that's being imported from the continent and further afield. So it's a really critical area, and I think we've kind of identified that. But still in 2024, we're installing around 20 times more gas boilers per year in the UK than we are installing heat pumps. So as a market, we really have to start turning the dial, and it feels like we've been talking about it for a long time around making this transition and this kind of hockey stick deployment that we expect to see in how we deploy heat pumps at scale, but it's still not happening yet. And what we're here today to discuss a little bit is kind of the barriers, what's stopping that deployment and what needs to change, both kind of in industry at a government level to allow those kind of levels of deployment to happen. Just to kind of introduce our speakers, if I want to just introduce Natalie first.
Hi, I'm Natalie. I work for Clarion. I am the head of Regeneration National, so I look at all of our regeneration programs across the country. And the case study you're going to see in a moment is one of the schemes that I've been working on in central London. Clarion are a housing association. We're the largest housing association in the UK. We have over 125,000 homes and a landlords to about 365,000 people. So yeah, we're pretty big.
Thank you. And Katie?
Hi, I'm Katie Taylor. I'm Business Development Director for GTC. We are an independent infrastructure provider, so we're installing around 4,000 utility connections across the new build sector, and have recently gone into partnership with Kensa to install their heat pumps across the developments that we're working on.
Thank you. So before we kind of get into the discussion around how we go about kind of scaling the technology, we just want to give a bit of an overview for those of you that aren't so familiar with the technology around how it works. So we've partnered with both Clarion in the retrofit sector and with GTC in the new build sector on kind of large scale schemes deploying this technology already. what we do at Kenza is we utilize ground source heat pumps and create what we call networked heat pumps to be able to heat homes and businesses. We do this through drilling vertical boreholes, so anything from a depth of 150 to 250 meters deep, where we harness the low-grade energy from the ground. We install the collectors, so the borehole probes go into the ground and backfill with some grout, and in operation we basically pump fluid through that circuit to pick up those levels of low-grade heat from the ground. So on a new build environment, we build the homes first, or install the infrastructure first, then the homes get built, we make those connections via a manifold, and then those manifold connections go out to the individual properties. So what we basically have is a network of collectors that kind of gather that low-grade heat from the ground and serve multiple properties, as you can see in the animation. And then what you get within each individual home is we have an individual heat pump within that dwelling. What that means is that all of the interconnecting networks, all of the pipe work that connects the heat pumps together is on the cold side, so we zero out any system distribution loss around the network, and all of the billing is done individual to each home. So the heat pump is basically an appliance within the home that's connected to that homeowner's electricity supply, and they just pay for their heat as they use it. And the heat pump provides 100% of the space heating and all of the domestic hot water to the dwelling. And one of the unique things about ground source heat pumps is we can also provide passive cooling. So we can connect an additional module to the ground array. We can take the low grade temperature from the ground and circulate that basically through a cooling fan coil into the dwelling and provide comfort cooling in the summer for very low cost, as well as heating in the winter. So that's kind of the overview of the technology and why we go about using it. And now we're going to kind of get into the main main part of the kind of discussion really is around how do we go about kind of scaling up that technology and what are the existing kind of barriers. So starting with you, Natalie, what do you think the kind of major barriers are for the housing sector in terms of adopting heat pump technology?
I think in terms of, for us, when we're looking at doing anything, it's looking at what's best for our residents. So we want to make their houses as green as possible. We want to do as much retrofit and bring their bills down. There is a bit of perception that it won't bring their bills down and it's complicated. So really, for us, it's about changing that mindset and changing the perception of that it's very similar technology to what they have at the moment, but it's producing communications that they're going to find easy to understand and to kind of get their buy-in. Without their buy-in, that there's no point in us scaling up or using this new technology. So it's about really having workshops with our residents, taking them through the process to get their buy-in, and then for them to get excited about the new technology and want to be a part of it. So we start really from the really early stages when we're looking at any regeneration, is to work with our residents right from the beginning to explain the new technology and the options that are available to them, so that when the point comes when they're moved in, it's not a big surprise to them. They're already kind of in that mindset, they're going to be used to it, they know how it's going to work. And then the support then we get from our colleagues at Kenza that install that know that they're going to be there to support our residents if they're confused by any of it, or if anything doesn't, but if they want to have any questions or they feel that they're struggling with that technology, it's the support we get from our partners to make sure that that relationship continues for the first, the journey along the way, those first kind of few months and maybe into years, so then it just becomes a normal part of their daily life. So that's really where we're coming from when we're looking at installing any new technology in our schemes. Yeah,
absolutely. I think having been in the industry a really long time, I think the technology itself is really well developed. There's more innovation going along all the time, and controls are getting better, compressor technology, low GWP refrigerants and all that kind of technical stuff. And some of the sessions earlier going into kind of a lot of detail around the technicalities around it, which is great, but it all sounds a little bit kind of complex and distant. And actually a key part of the challenge is like a communications challenge rather than a technical challenge. It's getting people to understand and be comfortable with it as a technology class rather than anything else. So moving on in the kind of new build sector, so GTC kind of relatively recently making that transition from kind of gas infrastructure networks into the deployment of heat pumps. Looking at it moving forward, do you think the major kind of barriers are for for that transition for developers?
Yeah, I think it's just making sure that the house builders are comfortable with the change in the delivery model of it. I think GTC, we're very much a trusted brand in the house building sector anyway. But as Natalie said, it's really about that educational piece of them understanding what it is that we're installing for them.
Sure. And then how about from a kind of a policy and regulatory point of view? Is there anything going on at the moment that could be helpful or that's causing a barrier at the moment?
Yeah, I mean, heat networks are not regulated at the moment. We are a founding member of the Heat Trust, and we have over 10,000 providers on heat networks at the moment. But we're very much working with the local authorities to make sure that they understand the assets that we're going to be putting in the ground and that they're comfortable with the adoption process.
Sure. And then what about on the future home standard side of things? Like feels like we've been talking about it for quite a long time. There's still not a definitive kind of date around that.
Yeah,
what's the view there?
We thought, Future Home Standard 2025, what we believe it to be at the moment is that the papers are going to be laid to government in May, June this year, and they will lay with them for a year. So in theory, Future Home Standard, if a site hasn't been started or registered, Future Home Standard will need to come into play in July 2026.
And how do you think the development sector in general are viewing that change? Are they all kind of rubbing their hands, can't wait for the transition, or like what's you're kind of quite close to a lot of these guys, so what's the view of the sector?
I think that they're definitely sort of sitting back a little bit at the moment. They've obviously seen that the timescale has pushed back, and they're waiting to see what the decision is, whether that's on a per plot basis or whether it's going to be on a phase basis or whether it will be for the whole site. Certainly some house builders are very keen to make that transition away from a fossil fuel and start testing the new technologies. So it's a real mixed view at the moment in the market.
And how about for kind of asset owning developers, so kind of housing associations that are building, like to me, I'm sure you kind of reiterate the point, but for anyone that's taking a long-term view around kind of adopting a new build home, putting a gas boiler in it right now probably doesn't make a lot of sense, right?
No, because certainly if we're working on behalf of a lot of house builders that will be selling housing stock on to asset owners like yourself, there'll then be a whole new program that you'd need to get into if you're not forward thinking in terms of what technology is being installed in your properties.
Yeah, we have our 2020 plan, so we're not installing gas boilers in any of our new build properties or our regeneration schemes. So yeah, we wouldn't accept those properties if they had the boilers in them. Yeah,
it absolutely makes sense. I mean, again, having been in the sector for quite some time, we first talked about zero carbon homes in 2016. I think we've built something like 1.6 million more homes since we said homes would be zero carbon in 2016. So that's another 1.6 million homes that are now going to have to go through a retrofit program that we could have taken care of if we'd been more advanced with the policy in the first place. And so it's definitely a frustration with the time that it's taken to come through. But now it seems like we're really close to taking that decision. But it's also really positive that beyond the legislation, we have companies like Clarion and councils that we're working with, like Bristol City Council, who are kind of going above and beyond and going faster than the legislation and creating their own mandates to say, well, we won't accept fossil fuel boilers anymore because regardless of legislation, it doesn't make sense to us from an asset ownership point of view.
I'm just going to say that another thing that we are finding is in planning conditions that they are specifying that a heat pump needs to be installed as part of that. So certainly we've had sites coming forward where we've installing ground source heat pumps because the council are specifying that we need to do that ahead of Future Home Standard.
Okay, and then just from a housing provider's point of view, is there anything else from a policy or subsidy or regulatory point of view, Natalie, that would be helpful, that would help to kind of accelerate the pace of change in that sector?
We're looking at different funding, all sorts of funding to try and get that, private funding as well, because at the moment government are not funding all of the decarbonisation. So we are looking at various schemes. And also obviously other challenges as well that we're having to look at, the installing, the upkeep, the skill sorted, all of those kind of things. So I want to make sure that through when it's installed, that we're taking on as much through via social value, skills and apprenticeships as well. So it's all of those kind of challenges as well that we're having to look at as well. But we're very keen to get on with it. And if we tackle those challenges as we go along, we're hopeful by the end of it, then we're already halfway there.
Yeah, absolutely. That kind of skills shortage bit is something that gets kind of talked about a lot in terms of kind of concerns around, are we able to deploy this technology? I think from Kenza's point of view as a manufacturer, again, we've been supplying ground source heat pumps to the UK market for the last 25 years, and the technology is actually really well advanced, and most of the gap is actually in the kind of design, specification, application elements of it, like the physical kind of installation of the heat pump. So for the installations that we did with Clarion, we're going to talk about in a moment, we're using local supply chain to do that. So there's a network of kind of gas safe accredited kind of contractors all up and down the country that can do the pipes and the wires. There's not really a concern around the physical skills of being able to fit it. I think where the gaps are is around how we develop the design, the application, and the technical capability to get the things specified is where some of that kind of gap is.
And also how we maintain it going forward as well. So once it's installed, making sure that there's the skills there to be able to maintain the equipment as well going forward.
Yeah, absolutely. Kind of taking that kind of long-term view on it, particularly with where a ground source heat pump's concerned. When we work with providers like Clarion, a lot of it is around like how we develop that lifetime cost model, and if it's very expensive to operate and replace and maintain in the future, then that's a huge barrier. So again, a lot of work goes into how we design and develop these schemes to kind of minimize the amount of cost that goes into it in the future. So then kind of the next bit is around kind of the actual talking of those technical challenges. So when we get down to the individual project level, Katie, what are you finding are the kind of technical challenges on site to be able to get heat pumps specified rather than people sticking with gas boilers in the interim?
I think one of the main drivers is the electric capacity. At the moment, we're applying for points of connection. Air source heat pumps doubles the electric demand on the network, and the incumbents, the distribution network operators, cannot keep up with the reinforcement that's needed to be able to deliver the capacity to the sites.
And so what's the scale of the problem there? What sort of problems are we solving for these developers?
Well, you'd be looking at having to install primary substations, many more substations on a development, whereas the ground source heat pump solution enables us to keep the ADMD down at a very low level, something what we'd see around a gas heated property. So we're enabled to keep building going forward and not put a stop to construction because there isn't the capacity there to deliver to those properties.
So just to wind back on that for anyone that's not familiar, ADMD, do you want to explain that for us?
Working in the utility sector, we like to talk in code. The ADMD is the average demand that a property would use.
Okay. And how does that help developers? So I know we worked on a project recently where we were able to kind of short circuit the amount of time that it took for them to get connections for a development. What sort of impact does that have?
Yeah, we worked on a development down in Sussex where they didn't have capacity available until 2037 for full site capacity. So by deploying the Kenza solution, we've been able to deliver full site capacity by 2030 and keep their build program running.
Excellent, thank you. So, and then the final bit for you, Natalie, is around back to that kind of comms piece, and how do we deliver that level of kind of consumer confidence? How do we make people comfortable that when we take out a gas boiler, everyone's really familiar with when you burn stuff, it gets hot and I'm going to feel warm. We're using a technology that people aren't so familiar with. What do you think we need to do in the housing sector to get like the residents, but also the housing providers themselves comfortable with that as a transition?
I think just communication is key. I think, where we've had so many site visits to come and actually have a look at that technology, that's really, really helped. With residents, it's just making sure that they're involved from the start, giving them opportunity to come to the workshops, to see the technology, get them out again on site visits to actually see it in action, it's getting them to speak to other people that actually have that technology, and just explaining that it is different, even though it might kind of look the same, and it's just, being with them and tailoring your communications to your residents. On the estate, you're going to see we had a lot of elderly residents, so there was quite a lot of hand-holding and explaining, but also just, videos as well really do help. So it's just making sure that they're comfortable, making sure that they know that you're there for them, and that there is, if anything goes wrong, we're there and we can sort it. But it really is just tailoring your communications to your residents and letting them be a part of it from the beginning.
Excellent, thank you. So a kind of nice segue into the next section, where we're going to talk about the Sutton Dwellings project in a little bit more detail. Just going to introduce it with a brief video that just explains a little bit about the scheme, starring our very own Dr. Stuart Gadsden. So we'll just show you the video and then we'll have a bit of a chat about the project, if it works. Oh, too many clicks.
Welcome to the Sutton Estate in Chelsea, in the heart of London. This is one of the UK's oldest social housing estates, owned by Clarion Housing Association. We are here today to show you how we install ground source heat pumps into these flats to make them fit for the future. Come with me. So in this area, we drilled boreholes down to about 180 metres deep. The boreholes collect lots of low-grade energy that we then take upstairs into the properties where we connect to the heat pump. We're able to install ground source heat pumps in tight urban environments and into buildings that are over 100 years old. Come with me, we'll find out a bit more. And here we are inside one of the flats. We have the Kenza Shoebox ground source heat pump. This is providing all the heating and hot water. We've installed 81 of these across the block. This is connected to the radiators inside the property, and even on the coldest day of the year, the residents are lovely and warm. It has the lowest running cost of any heating system. It also has the lowest carbon emissions, so we're decarbonising heat for the future.
Nice. So that's a very brief intro to the scheme, just to give a bit of a visual and an idea of what we're looking at here. Natalie, do you want to kind of go into a little bit more detail and just explain kind of the background to the Sutton Estate and how the project came about?
So the Sutton Estate is in the heart of Chelsea, just off of the King's Road. It was built in the early 1900s. During the kind of 80s and 90s, it had a programme of refurbishment work. And when we got to the 4 blocks that you see there, they actually ran out of money, which was okay in the 80s and 90s, but when decent home standards came in, we had to do something with those blocks. We did look at regenerating the whole estate, knocking everything down, but we weren't successful with the planning. So we had to then have a look at those 4 blocks to see what we could do to bring them back into life. What we had there was 159 flats, mainly bedsits. They didn't meet decent home standards, kind of very tiny little kitchens with a shower at the back. That used to be the old coal store. So what we decided to do was to refurb the blocks, keep the fabrics. We completely knocked through. They actually look quite beautiful knocked through. They look like New York loft apartments. But we turned 159 flats into 81, and that's a mixture of 1, 2, 3 and 4 bed family accommodation. At the time, like I said, because we're not installing gas boilers, we had to look at other ways to heat the homes. We couldn't use air source heat pumps because they were mansions, so then we kind of started to look at ground source heat pumps, and that's where Kenza came in. We've also done a lot of placemaking on the estate. It's quite harsh. So we have put in a programme of landscaping, which was finished as well with those 4 blocks, and it actually has won a landscape award because of the urban design. So once the rest of the estate is having some planned maintenance works at the moment, once those completes, that landscape will continue. So that's how we came to refurb the blocks and work with Kenza.
Excellent. So do you want to go a little bit more into kind of what the other options were, and I guess maybe that strategic decision in the first place to not have gas? And that's kind of the key thing that led to the heat pumps coming about.
Yeah, so just Clarion have decided that there would be no gas boilers installed in any of their new builds or any of the regeneration schemes. So that's when we, made a decision that we had to look at other options. So that was, other things were considered, but like I say, the air source wouldn't have worked because they were mansion blocks, There's no connectivity, I think, to get onto kind of a centralised system to connect them to. So really, we were just left with looking at ground source.
And initially, kind of having been involved right from the start, there was kind of the approach was, we don't think this is going to work, but like, can we do it? And so there's a whole kind of process that we went through to say, okay, here's starting with the building load. Okay, what are we going to do to the building? Improve the fabric as much as we reasonably can. So internally insulating the building, upgrading the windows, all the kind of basic fabric measures. From there, kind of taking an assessment of, okay, how much heat do we need? And once we understand that, we look at the kind of geology in the specific location, and we look at all of the kind of barriers to getting into the ground as well. So whilst it's in Kensington, it's actually not too close to the tube station, so that was kind of the first major risk that we had to kind of get past. But there is quite a lot of stuff going on in the ground, so we found there's like an air raid shelter, underground air raid shelter on the site that we had to kind of plan around all of the existing services, so it was quite tight, but we were able to develop a design and a proposal that where we can get all of the infrastructure that we needed into the ground to be able to serve the estate. And just for me, the best thing about this project as a demonstrator is that the perception of what can be done with heat pumps, this kind of breaks all of them. It's right in the centre of London. They're 5-storey flats. They're 100-year-old buildings. It's in a kind of dense urban environment, yet with all of those constraints, we've fitted a ground source heat pump solution there. And kind of part of the message is, well, if we can do it there, then we can do it in most applications across the country. So that perception of barrier of, oh, well, we always have to use gas for these types of building doesn't exist. Like, there are the options out there. So just in terms of, from a delivery perspective, Natalie, what do you think the kind of key kind of challenges were in the delivery part of the scheme?
It was an incredibly tight site. There's somebody here that was actually so it was incredibly tight. So the buildings are very close together, and also we'll have our planned maintenance works carried out at the same time. So there was scaffolding throughout the whole of the estate. So just from a logistic point of view, that was very tricky. Also, residents, obviously, they were seeing what was going on, so we had to communicate with them. When you hear the word boreholes, they think it's going to be very noisy, very dirty, it will take a long time. Actually, it was none of those things. It was very, very quiet. We were very surprised. We got no complaints from any of the drilling at all. So, again, it was the communication of telling people what was going on. But I would just say the main challenges were just that it was a tight site and there was lots going on. Lots of scaffolding, lots of other building work. So that was the main logistic problem of getting the timings right, and the programme working with the other teams on site.
Yeah. Having all of the trades running at the same time, everybody working to their own deadlines. Definitely created some tensions and some fairly hefty conversations at times, but we worked through it, and from a program point of view, we were able to kind of deliver on program, which was great. Now it's done and dusted. How are you finding the results? I know it's only relatively recently people are moving in, but from a like that kind of transition and bringing people in, how are people finding it?
So only people have just moved in, so we always carry out a post-occupation survey, a little bit afterwards. But at the moment, we're finding it's okay. We're not having too many questions about what's going on. I think it's just changing the mindset. What we just have to keep reminding people is that it's on for longer, lower, and that's just kind of what we keep repeating to residents. But so far, it seems to be working okay. People are very happy in their homes. They're beautiful flats, and I think certainly they don't look that different. There's still a radiator. There's still, the shoebox is the boiler. So it's quite similar, once they're in. So it seems to be going well.
Excellent. From a controls interface point of view, we took the decision to go with really simple controls. So we basically specified the same set of controls that you would use, or that Clarion use elsewhere in their stock for their gas boilers. So from an internal point of view, being able to support that transition and understanding the controls, like that's one key element, and make it really simple. We do have options to use more sophisticated controls, and maybe Kate will come on and talk about that in a little bit more detail. But from a smoothness of handover point of view and that understanding, like that really kind of straightforward controls is quite an important thing. From a carbon saving point of view, again, we've done the calculations. We think it's somewhere around a 75% carbon reduction, switching to ground source heat pump from the gas boilers. And with all of the rest of the works, we had the kind of as-built kind of SAP calculations come through. So we think we're generally around a kind of high C, low B, dependent on the house type, SAP calculation. So brought them right up to standard. So yeah, overall, really a great scheme. So that kind of wraps that one up. Katie, I don't know if it's worth just talking about from a new build perspective. We're not quite on site yet, but talk about a couple of the schemes that we've got in development and what we're looking to do moving forward.
Yeah, so we've got 6 sites that we've contracted. So we went into partnership with Kenza in June last year. We've definitely had some interesting conversations with developers. 6 are secured. We're on site next month to start drilling on one of our developments. That is a site that we actually contracted back in 2012 before we knew about Future Home Standard and it was going to be gas heated. There isn't any capacity available in the local distribution network to be able to deliver electrically heated plots. So we've been able to make a smooth transition with it being a localized heat network that we can deliver those units with the ground source heat pump and meet the planning requirement as well.
Thank you. And then just to kind of wrap up, we'll go into some kind of Q&A in a minute, but just kind of as a final piece from each of you, if there was kind of one thing that could be implemented or changed or just kind of got a magic wand that you could kind of wave to say, this is the thing that's going to change the kind of pace of heat pump deployment in your sector, what do you think that would be? Katie, if you want to go first.
My takeaway point would be that we need to be using energy much smarter than we have, rather than just doubling the electric demand and paying for additional infrastructure. Also, using the energy in the home smarter. When we're installing our ground source heat pumps, we also install so we have a sister company called Passive, and so Passive have a smart thermostat business which can then increase the coefficient performance of Kenza's ground source heat pump, and we were seeing around a 30% reduction in the homeowner's electric bill as well.
Thank you. And Natalie?
I think for us it's just continuing with that communication piece, because we are, replacing the boilers, retrofitting. So it's carrying on, educating our residents, making sure they're comfortable with that technology, getting their buy-in, and just really changing the perception. I think they do get scared. I think there's been some pieces in the media, and they come to us and they all find it all very scary. So it's really kind of creating that communication that they find simple, easy to use, and getting their buy-in from the beginning, because it will improve, their bills, improve their homes, and it's just carrying on with that communications piece.
Excellent, thank you. And I think from a Kenza perspective, I think for the transition to really land at scale, we have to be offering something that's better. It has to be better than the incumbent technology. So it has to be cheaper to run, it has to be easier to control, it has to be smarter. It has to be easier to access, and that's kind of a key challenge at the moment, is how you get access to the heat pump market. I think, a lot of time it's a distressed purchase, particularly in the kind of able to pay market, that triggers the move to heat pumps. So again, it's just ensuring that that's better. I think it's going to take a real collaboration across the sectors, through technology providers, innovation, but also through kind of government and policy, being able to implement the right levers so that heat pumps become the natural choice. The longer we continue to rely on short-term subsidies to kind of trigger the market, I think that's actually, you're kind of reliant on a cycle of subsidy, and we have to kind of move away from that. And that's only going to change when the sector has the certainty that the heat pump kind of transition is going to happen. So that comes from government, but also around running costs. Like, there's a lot we can do in terms of kind of innovation and making the technology better, making heat pumps more efficient. But a big part of the operating cost of the heat pump is actually the cost of the electricity. Again, we can better deploy that through smart controls and using time of use tariffs and access cheaper electricity there. But actually, the key policy switch actually is removing the subsidies from the cost of electricity, and moving that onto gas, moving that onto the dirtier fuel. And that's going to be one of the key things from my point of view that's going to really enable that transition. Politically, it's a very difficult point. It's not an easy thing to do. And what you're trying to do is make a decision in a 5-year term that has kind of a 20-year effect. So it's a very difficult thing to pass. But actually, that's going to be, for me, the key trigger point is when all heat pump variants will naturally just be cheaper to operate. That's when we start to see that real kind of transition and a real pull to the market, because at the moment, frankly, gas is just too cheap, and there's not the motivation to move away from it. So that kind of wraps up the session. We've got kind of 10 minutes left for a bit of Q&A. If there's anyone in the audience that's got a question around either kind of new build deployment, housing sector, or anything technical, we're happy to spend the last few minutes answering any questions.
Hi. I'm not going to talk about Sutton Dwellings, but it's a very interesting, difficult project. 12 metres between each of the building blocks. But if you could build there, you could build anywhere. The air raid shields was a big problem for us, as you know. But coming back onto the control units, do they learn in advance how the energy requirements of each of the users require?
Yeah, so the thermostat looks at the heat loss calculations of the building. It will look at the projected weather forecast. It will start to look at how the resident uses their home and start to play with the temperature. So when we talk about low flow temperatures, that the thermostat will then start to play around with those temperatures, making sure that the resident is warm from the times that they've put in the smart thermostat, but heating it in the most efficient way.
Yeah, so in a way, it's like thinking about underfloor heating, where you have to plan in advance to heat up the floor, to heat up the space. With a ground source heat pump, you actually have to get the glycol up into the unit and then heat up the system as such.
And the point with the smarter controls are all of that thinking and programming is done by the thermostat. So as an end user, all you have to do is say, I want to be warm at these times, and then the thermostat does all of the optimization and sets the flow temperature and decides when to turn on and off to make it as cheap as possible, but meet the heating profile that you've set.
And you were mentioning about the tariffs, etc., but battery technology is coming cheaper, so there's a possibility of saving up battery power to actually power up the units when electricity is more expensive.
Yeah, for sure. So first of all, before you even need a battery, you have the thermal battery of the building itself. So you understand how quickly the building kind of heats up and cools down. The thermostat will learn that. If you supplement that with like a thermal battery as well, then you can further extend those periods where you can use the cheapest possible electricity using like an Octopus Agile tariff, charge everything up at very low cost electricity, and then ensure that you have the heat available at the times you need it.
Can I ask a question about keeping the buildings cool in summer? Does the ground source heat pump system facilitate that?
Sure. Katie, do you want to do that one?
Yeah, you're probably more best placed to talk about it.
I like to put you on the spot. So
when we're drawing heat out of the ground, there is a manifold that can be installed as part of our heat network, so that it can bypass the heat pump and use passive cooling through either MVHR or through a modular unit to cool a room.
Thank you. Does that answer the question? So, we just use that coolth that's in the ground and just reject the waste heat out of the building, put it in the ground way. So it's a real unique benefit of ground source. The key thing about it is we're only running the circulating pump. So we're not running a compressor, so it's not like air conditioning. So it uses a fraction of the amount of energy. And that's going to, again, as climate changes, as summers get hotter and we have and buildings get more insulated and more airtight, overheating in summer is going to become more of a problem than underheating in winter. And to be able to provide that cooling, but for an absolutely minimal amount of electrical energy, is that's one of the key features of benefits of transition to ground source. Thank you. Got one more question here.
I'm interested in the what you said about the air source heat pump being such a large draw on the electricity network compared to ground source. Can you explain that in slightly more layman's terms?
Yeah, the air source heat pumps have various different profiles. So when we design an electric network, it's very much about making sure that we're not that we size the network, that we're not going to be putting unnecessary peaks on the network and making it fail. With the air source heat pump being sat outside, they have various settings like defrost settings, and when a house builder installs air source heat pumps, all of the same manufacturer, they all seem to have this setting at the same time. So we can see quite often, maybe at 1 o'clock in the morning, that all of a sudden we've got a huge peak on our network, and that's why we need to factor in that additional load that the ground source heat pump, with it being a much more constant temperature, it doesn't have that impact on our electric network. Yeah.
Hello? Is it working?
Yeah, got you.
Right. I only joined halfway through this talk, so I don't know whether you've covered this, but is it... Previously, ground source heat pumps were a lot more expensive to install. Is it because you've got bores that it's actually relatively cheap now, or isn't it? And who does... if you're making a bore on site, or many, how many flats, if you have got 81 flats, how many bores do you have to provide in order to get sufficient power for it, or whatever it is? And do you have to make planning applications for boring on a site like this? I'm sure you do, don't you?
Yes.
Anyway.
So yeah, I'll try and... Do you want me to pick those up?
Is this on an individual basis, or is this on a scale, a house building site?
It would be, several flats in a block, but not 81 or anything.
Okay. Probably one for you.
Sure. So I think, try and answer all of those questions. So for Sutton Dwellings specifically, across the 81 apartments, it was 27 boreholes to provide the infrastructure. Drilling boreholes, particularly in urban environments, is actually quite expensive. There is still a fairly significant cost to it. The benefit of the ground source network and the infrastructure is it lasts a really long time. And during that period, it has very little requirement for kind of service and maintenance. There's a very low operating cost. So working with the GTC and their funders, and also working with our funding providers, we're developing business models that allow us to fund the ground array infrastructure in exactly the same way that the big utilities at the moment fund gas. So if you want a gas boiler for a new home, you don't pay up front for the gas connection, you don't pay all the cost to bring the pipe to your home, you just pay a standing charge as part of your bill, and over a 20, 30, 40 year period, that pays for the cost of that network. And we're looking at deploying exactly the same mechanism for both new build and retrofit sector, whereby that cost of deployment is spread out over a really long period of time to make it accessible to the market. At the moment, that's focused on kind of new build development and kind of housing sector, because we've got single decision makers and we can set up the funding agreements with them over a long period. But our kind of moonshot, where we want to get to by kind of end of the decade, kind of mid-2035, is to be able to roll out this kind of infrastructure in areas for kind of private domestic residents. So come to your street, put ground array networks in, put connections ready, and then when people start choosing to take their gas boilers out, we can then connect them to our networks. So that's kind of the moonshot, that's where we want to get to. So right now, still quite expensive, probably not all that accessible for many individual homeowners, but that's where we want to get to, and that's why we're working with both GTC and housing providers like Clarion to scale up how we deploy the technology, drive the cost down, and develop these kind of funding models that allow us to deploy the technology at increasing scale.
Yeah, so our business model is all about owning and operating assets. So certainly in the new build sector, we'd be looking to make a level of investment which would bring the per plot cost down to something in line with what you'd see for an individual air source heat pump, because we're going to maintain that network over, in perpetuity over a long period of time.
And just on that, for us also, it means that we don't have to carry out gas safety checks. So with gas boilers, every year we have to go in and carry out a gas safety check. With the ground source heat pump, we don't have to do that anymore. So that's another cost saving as well for us.
Fantastic. Okay, thank you very much for the questions. That brings us to the end of this session. Thanks very much for listening. Before we finish, very quick thank you to Katie and Natalie for joining the panel. Really appreciate that. Thank you. Thanks everyone for listening. If there are any more questions, Stan's just here. Please come over and have a chat. Be happy to talk further. Thank you very much.